2.4 lesson is more about solving linear equations. So we're going to be graphing and working more with lines. These are the equations that you should have in your notes. We're adding a couple more today. So the direct variation one, y equals kx. Slope-intercept form is y equals mx plus b. Your point slope form is y minus y1 equals m times x minus x1. And standard form is ax plus by equals c. Your k in this direct variation equation is just your constant of variation or your slope. Your m here is your slope, so that m and that k are the exact same thing. And the b here is your y-intercept. This one does not have a b here, so you would just put a 0 in that spot. Point slope form, this y1 and x1 is where you put the point that they give you, and then this m and this m are the same thing, just stand for slope. And then standard form is ax plus by equals c. A, b, and c are just going to be whole numbers. You cannot have fractions or decimals in this form, so if you do, I'm going to show you how to get rid of them. The first examples are going to be writing the equation giving a point and a slope. So I'm going to give you a point and a slope, and then I just want you to put it in point slope form. So this is going to be our x1 and our y1, and that 1 just means what is the x of the first coordinate they give you, what is the y of the first coordinate they give you, and then our slope is our m. So we have our equation and we just plug in our numbers. So we would have y minus our y1, which is 2, equals, then our slope is 3/5, x minus, then our x1 is -5. Notice how we have two negatives back to back, so those would cancel out to be positive here. And then everything else we would keep the same. Now to get from point slope to slope-intercept form, if they asked you to, you would just go ahead and do 2 steps. So you would distribute this 3/5 or whatever your slope is, so 3/5 times x and then 3/5 times 5. And when we do that, we get 3/5 times x is 3/5 x. And then over here, when we distribute to the 5, just make that a fraction. Think top times top, bottom times bottom. So 15 divided by 5, which is 3. And then our second step, we're going to add or subtract this y1 number over. So it's -2, so we're going to add 2 on both sides. These 2's cancel out, so we have y equals 3/5 x plus 5. So this form right here would be our point slope form, and then this second form is slope-intercept form. Please make sure you read the directions so you know what form that I am looking for. Number 2, we have a new point and a new slope, so 7, -1, and our slope is -3. So we write down our equation for point slope form. Again, this is going to be our x1 and our y1. In point slope form, this y and this x, the first ones, you leave them alone always. So it's going to be y minus, then our y1 value, which is -1, equals -3, our slope, and then x minus our x1, which is 7. And then from here, again, if we have 2 negatives back to back, we're going to cancel those out to be positive, then we leave everything else the same. So that would be our point slope form. Now to get from point slope form to slope-intercept form, we do our 2 steps. So we distribute first. So if we distribute this -3, we have -3 times x is -3x, -3 times -7, positive 21. And then I'm adding 1, so to undo that, I would subtract 1 on both sides. These 1's cancel out, so I get y equals -3x, and then 21 minus 1 is 20. So that would be my slope-intercept form. Now, depending follow-up questions, if they wanted you to graph it, it's probably going to be easier to have it in slope-intercept form, so then we can see our y-intercept is 20, so we'd start at 20, and then our slope is -3 over 1, so we'd go down 3 over 1, down 3 over 1, and we make that line. Now, if it was in point slope form, we just use that point and that slope to be able to graph it. So plot this point first, go to 7, -1, and then our slope is -3, so down 3 over 1, down 3 over 1. Both of these equations, we're going to get the exact same lines if we take a look at the graphs. Now, our third example, I'm going to give you a little bit different information. We're going to do the exact same steps, but instead of giving you a point and a slope, I'm just going to give you 2 coordinates. So if I give you two coordinates instead and I don't give you a slope, we need to use our slope equation to find it. So think about our slope equation, difference of our y's divided by difference of our x's. So we have our x1, y1, x2, y2. And that just means what is the x and y of our first coordinate, what is the x and y of our second coordinate. So then we take our 8 minus 2 and then 5 minus 3. We simplify across the top. 8 minus 2 is 6. 5 minus 3 is 2. 6 divided by 2 is 3. Now we have our slope is 3. We can choose either point. It doesn't matter which point we use, just pick one. You're not going to use both of them. So I'm going to choose this first one. Choose which one looks easier. And then y minus our y1, which is 2, equals our slope was 3. And then x minus our 3 here. And that would be our point slope form. And then if we want it in slope intercept form, we do the same two steps. We distribute first. So 3 times x is 3x. 3 times negative 3 is negative 9. And then we're going to add this 2 over to both sides. Those 2's cancel out. So we get y equals 3x minus 7. Alrighty, this next example, I'm going to give you 2 points also. And we're going to do the exact same process. So first step, we need to find our slope. So we take the difference of our y's divided by the difference of our x's. So 7 minus 0, 0 minus negative 5. So 7 minus 0 is 7, 0 minus negative 5. We cancel out the two negatives, that is now positive. So 7/5, we plug that in for our slope. We pick one coordinate, so I'm going to pick this first one. Pick whichever one looks easier. So y minus 0 equals 7/5, x minus negative 5. My two negatives cancel out to be positive, and then that is my point slope form. If I now want to put it in slope intercept form, I distribute that slope. So 7/5 times x is 7/5 x. 7/5 times 5, make that a fraction. Think top times top, bottom times bottom. So 35 divided by 5 is 7. And then this y minus 0 is the same thing as just y. Okay, you don't need to add the 0 to both sides. And so then my slope intercept form is y equals 7/5 x plus 7. Now the next couple examples, I'm going to be giving you an equation and I want you to put it in standard form. Please remember that our standard form is ax plus by equals rc. So we want to put these in standard form. Our a, b, and c need to be whole numbers, no fractions, no decimals. They can be positive or negative though. So this first example, we have y equals 3/4 x minus 5. So the first thing that I notice, we have fractions, and we can't have fractions in standard form. So I'm going to multiply by the least common denominator to get rid of my fractions. So in this one, if I look at my denominators, I just have 4 in the denominator. So I'm going to multiply all three terms by 4. So I'm going to distribute this 4 to everything. So 4 times y is 4y. Now 4 times 3/4. Make this a fraction, think top times top, bottom times bottom. So I get 12 divided by 4, which is 3x. And then 4 times negative 5 is negative 20. Now I have no fractions, so that is good. Then I'm going to keep solving for it. Now standard form is different because the other equations all have the y by itself. Now standard form, they want the x and the y on the same side. So now I'm going to have to move this x over. So it's positive 3x. So I'm going to subtract 3x on both sides. They cancel out. So these are not like terms right here, so I just write them next to each other. I'm going to put my x first, then my y. So I have negative 3x plus 4y equals negative 20. Now instead, if you had all these signs the opposite, so this a positive 3x, this a negative 4y, and equals a positive 20, then that would be an acceptable answer. So either of those I would count correct. Let's try another one. So this one has decimals. So again, we can't have fractions or decimals in standard form, so we're going to get rid of those first. So anytime that you have a decimal, to move that decimal over one place to the right, we just multiply by 10. Okay, if you need to move it over 2 places to the right, you're going to multiply by 100. So for this one, we need to move the decimal over one place. So we're going to multiply everything by 10. Now, we cannot just multiply these two decimals by 10. We need to distribute this to all three terms. So 10 times y, we get 10y. 10 times 9.1, that just moves the decimal over one place to the right. So we get 91x. And then 10 times 3.6 is 36. And then from here, we got to get the x and y on the same side. So we're going to subtract 91x on both sides. Those cancel out. These are not like terms, so we're going to just write them next to each other. So we get negative 91x plus 10y equals 36. Now again, if you have these signs all the opposites, then this would be an acceptable answer also. The next type of problem that we're going to talk about is how to graph equations using their intercepts, their x-intercepts and their y-intercepts. So this method works really, really nice if it is in standard form. So this equation that I'm giving you is in standard form. I have ax plus by equals c. So how we find the x and y intercepts, we're going to plug in 0. We're going to plug in x equals 0, and then we're going to plug in y equals 0. And it doesn't matter the order in which you do this. So when I plug in x and y equals 0, so first off I'm going to plug in 0 for my x. I write everything else the exact same. Notice 3 times 0 is just 0, so I don't need that anymore. So I'm just left with 5y equals 15, which is a one-step equation that's easy to solve. So divide both sides by 5, and I get y equals 3. So since it's y equals 3 and x equals 0, think of that as a coordinate. X equals 0, y equals 3, so I would go 0 means none left or right, and then up 3, and that's where it crosses the y-axis, so that's my y-intercept. And then I do the same thing, but now I plug in y equals 0. So I plug in 0 for my y. I simplify this down, so 5 times 0 is just 0, so those cancel out, so I'm left with 3x equals 15. And then I divide both sides by 3, and I get 15 divided by 3 is 5. So then I can write that as a coordinate. 5 is my x, y is 0. So I graph that. I go over to 5, and then 0 is my y, so I don't have to go up or down at all. I plot that point. That is my x-intercept where it crosses the x-axis. I have 2 points. That's all you need to make a line. So then I make my line through them. Okay, so let's try another one. So this next one, again, is in standard form. So I have 2x minus 4y equals 8. Now another way that I think of it is just a cover-up. So if we cover up our y first, notice I'm left with 2x equals 8. So then that's going to be one of my equations if we look further down. 2x equals 8. And then I cover up my x term so that I'm left with negative 4y equals 8. So then I write that down, and that's my other equation. I'm doing the exact same thing, plugging in my zeros. So if it's easier or quicker to just think of it as the cover-up method, cover up your x, then cover up your y, you can do that. So then I solve for both of these equations. Negative 4y equals 8. Divide both sides by negative 4. So I get 8 divided by negative 4 is negative 2. Since it's a y equals negative 2, I go to my y-axis. I go down to negative 2, and I make my point. And then I solve this next one. 2x equals 8. They're multiplying, so I divide both sides by 2. So 8 divided by 2 is 4. Since it's x equals 4, I go to my x-axis, I go to 4, and I make that point, and then I make my line. Now, the last type of example we're going to go through in this lesson is talking about parallel and perpendicular lines. So the first thing we're going to talk about is parallel lines. So parallel lines, you need to put in your notes that if a problem talks about or refers to parallel lines, you want to know that parallel lines always have the same slope. So that this first example I'm giving you says a line parallel to y equals 6x minus 2 that goes through the point 1, negative 3. So what they did to us, they gave us this equation, and we want to find the line that's parallel to it that goes through this point. So that word parallel is huge. Parallel lines have the same slope. So this one has a slope of 6. So the line parallel to it is also going to have that exact same slope. So I'm going to then use that exact same slope of 6. I'm going to use this point that is on my new line, and then I'm just going to go through the steps of putting it in point slope form. And so then I have y minus my y1 value which is -3, equals my slope is 6, and then x minus my x1 value, which is 1. If they just want it in point slope form, you are done. If they don't, then we're going to go ahead and distribute this 6. So 6 times x is 6x, 6 times -1 is -6, and then these two negatives cancel out to be positive, so I'm going to subtract the 3 over on both sides. So then I get -6 minus 3, which is -9, and that would be my slope-intercept form. Notice my two equations, they have the same slope, different y-intercepts, so they are parallel lines like we were hoping for. Now, perpendicular, so if a problem instead uses the word perpendicular, what you need to know about perpendicular lines, they're not the same, but instead they're opposites and reciprocals. So what that means is, if I make the slope first off a fraction, opposite means different signs. So this one is negative, so line perpendicular to it is going to be positive. And reciprocal means that you have to switch the top and bottom. So this is 4 over 1, so this is going to be 1 over 4. So you have to take the opposite and the reciprocal. So my slope that I'm going to be using is instead positive 1/4. So I switched the sign and switched the numerator and denominator. And then my point, I'm going to use that point, 8, 5. I'm going to put it in point slope form. So y minus my 5 equals 1/4, x minus my 8. And then I'm going to distribute the 1/4. So 1/4 times x, 1/4 times 8. Make that a fraction. Think top times top, bottom times bottom. So 8 divided by 4 is -2 then. Then I add my 5 over. Those 5's cancel out, so I'm left with y equals 1/4 x plus 3. And so notice that those slopes are opposite reciprocals. The y-intercepts could be the same or different depending on where those two perpendicular lines crossed.